Hello everyone and welcome back to Germanic Science. In this tutorial we're going to be looking at a problem that has to do with calculating the density of a solid sphere and determining the uncertainty in the density. To do that we are simply going to start by finding the volume of the sphere using its radius. And then use the mass to calculate the density. Finally, we will simply use the error propagation to account for the uncertainty in the measurement. To do that, let's start by having a roughly sketch of the solid sphere. And let's say from here downwards, from the middle here, let's say we have the radius. So, from the question which we are given, it says the radius of a solid sphere is measured to be 6.50 plus or minus 0.20 in centimeter. And it has the mass which is measured to be 1.85 plus or minus 0.02 in kilogram. And what we are asked here is to simply determine the density of the sphere in kilogram per meter cube and the uncertainty in the density. So, first thing which I need you to understand, there are three formulas which are very important in order for us to solve this problem. The first formula is finding the volume, which is being denoted by capital letter V. Volume is simply going to be 4 divided by 3 pi r cube. Notice that this r simply stands for the radius. Another formula is for finding the density. Density is simply going to be rho m divided by v, where the m simply stands for the mass and the v simply stands for the volume. The last but not the least, which is the error propagation formula, which is going to be the uncertainty of the density, which is equal to the density into the square root of the uncertainty of the mass divided by the mass into bracket to the power of 2 plus bracket into 3 uncertainty of the radius divided by the radius plus bracket to the power of 2. So this is what you need for this problem. Feel free to grab your pen and write it down. So to begin solving this problem, let's start by erasing this. Okay, let's pick our data. From the data given, we are given the radius, which is this, and the value here is 6.50 plus or minus 0.20. Remember, the unit is going to be in centimeter. So we need to convert everything here into meters. This is the same thing as saying 6.50 divided by 100 in centimeter. And this is centimeter. Then we simply multiply that by meter. This will cancel out. 6.50 divided by 100, which is simply going to be 0.065 in meters. Therefore, our data here for the radius is going to be 0.065 in meters. What about the uncertainty of the radius? This is going to be dr, which is the same thing as saying 0.20 divided by 100, which is simply going to be 0.0020 in meters. And here we have our mass, which is already in kilogram. We don't need any conversion for that. For the mass, this is simply going to be capital letter A, which is going to be 1.85. It's going to be 1.85 in kilogram. So what we have next is the uncertainty, in the mass. Because if you notice here, we are having plus or minus 0.2 in kilogram, which the uncertainty in mass is going to be 0.02 in kilogram. So we said the first thing which we need to do at this point is to simply find the volume. And we said for us to find the volume is simply going to be 4 divided by 3 pi r cubed. So we can insert our values at this point. Volume is simply going to be 4 divided by 3 pi. What is the radius? The radius is going to be 0.065. Remember to put your unit which is in meter. And this is going to be in cube. 0.65 to the power of 3, which is simply going to be 2.75 exponential negative 5 in meter cube. The cube outside will multiply the meter. So we can say our volume is simply going to be 4 divided by 3 pi into bracket of 2.75 exponential negative 4 in meter cube. So what do we do next at this point? So we can simply rearrange everything by saying volume is going to be bracket of 2.75 exponential negative 4 in meter cube. You're going to multiply that by 4, then you multiply that by pi, you divide everything by 3. If you multiply 2.75 exponential negative 4 in meter cube, you multiply that by 4. What are you going to get? So this is simply going to be 1.1 exponential negative 3. So our velocity is going to be 1.1 exponential negative 3. Remember to put your unit, which is going to be in meter cube. Well, and same thing here, we need to multiply that by pi and divide everything by 3. So if you multiply 1.1 exponential negative 3 meter cube multiplied by pi, and this is simply going to be multiplied by pi divided by 3, and this is simply going to be 1.150 exponential negative 3, and our unit here is going to be in meter cube. So this is the value for our volume. So the next thing which we need to do is to find the density. And we say the formula for finding density is simply going to be our mass divided by our volume. And notice that the unit for our mass is simply going to be 1.8 kilogram. Isn't it? 85 kilogram, I made a mistake here. It's supposed to be 85. 85 in kilogram. I'm going to multiply that by volume, which is 1.150 exponential negative 3 in meter cube. You're going to divide that. So if you multiply the numerator by the denominator, your density is simply going to be 1608.7. Then the 2 unit, which is kilogram per meter cube, we're going to insert that here, kilogram per meter cube. And this is your density. So the additional 2 things which we have here is the volume and the density. What do we have in the, or you call it, values of the volume? We said is 1.150 exponential negative 3 in meter cube. And what we have as the density is going to be 1608.7 in kilogram per meter cube. Isn't it? Okay, let's work this out and continue writing, because we have a lot of things to write. So I'm going to continue from here. So the next thing which we need to do is to simply determine the uncertainty in the density. We can use the formula which we said, error propagation. The formula is giving us, that is the uncertainty of the density, which is equal to the density into the square root of bracket of the uncertainty in the mass divided by the mass to the power of 2, plus everything here by 3 upon the uncertainty of the radius divided by the radius to the power of 2. So at this point, we can insert our value by saying the uncertainty of the density is going to be, what is the value for density? The value for density is 1608.7 in kilogram per meter cube. This is going to be 1608.7 in kilogram per meter cube. So we can put in our bracket by saying what we have at the numerator, which is the density of the mass, so the uncertainty of the mass. This is simply going to be, we're going to pick the one in meters, isn't it? And at this point, this is going to be 0.02 in kilogram divided by what we have in meters here, which is 185 in kilogram. 1.85, I mean, in kilogram. Notice that the kilogram here and here will cancel out. So what we have here plus what we have is going to be the bracket of 3. What is the uncertainty of the radius? Uncertainty of the radius is going to be 0.0020 in meters. You are going to divide that by 0.065 also in meters. This will cancel out. And remember, from the outside of the bracket, we're going to have 2. So if you divide 0.02 divided by 1.85, what are you going to be left with? This is going to be the square root of what you have here is going to be 0.0108. Remember to put the square root is going to be plus. If you divide this 0.002 divided by 0.065 and you multiply that by 3, and this is simply going to be 0.0923 to the power of 2. The square root of these two is simply going to be, for this first one, it's simply going to be 0.123117. You're going to plus that by this, which is going to be 0.00852. So the square root of everything here, which is simply going to give us, no, not the square root. First, we need to sum it up. If you sum everything up here, your final answer is going to be 0.0929. So what is the square root of before then? After you sum it, what you're going to be left with is 0.008637. The square root of this, as this, is simply going to be 0.0929. So this is it. So remember, from the outside we have 1608. So 1608, if you multiply it by this value, which is going to be 0.0929, your final answer, let's write it just here, which is the uncertainty of the density is going to be 149.4 in kilogram per meter cube. So the density of this sphere is approximately 1609 kilogram per meter cube when the uncertainty plus or minus 149 kilogram per meter cube. So this is it for this problem, and I hope you find it helpful. Please, if you do, just do me a favor by subscribing to Germanic Science. Thank you for watching and see you next time. Hello everyone.